Okay, so this is the circuit that we have for the eyes, which light up. So what do we already know? We knew that this side was positive, and then this side was negative, and that our current, which is going counterclockwise, was 1.42 amps. So since this is a parallel circuit, we knew that the voltage drop would be the same at each light. So like over here, the voltage would be 3 volts, and then over here it would drop to 0 volts. So we know the beginning current, which would split off into 3 equal parts at each light, and we know the initial voltage. Well, yeah, the overall voltage. So we could have just used Ohm's law, which is voltage equals current times resistance. So our voltage was 3 volts equals 1.42 times resistance. So our overall resistance, meaning like the resistance of all 3 lights together, would equal, well, if you divide that, it would equal 2.11 ohms. And like I said before, this is the total resistance. So we could, and since the lights are the same, it's just the color that's different, we could just divide this by 3. So the resistance of each light would equal 0.70 ohms. So we know the resistance of each light, and we know that the voltage drop for each light is 3 volts. So like, it's just a current that's different. So like right here, it would get some of the current, here's some of the current, and here's some of the current. So we could just divide 1.42 by 3, meaning that the current at each, like, I guess, what would you call that? At each section, I'll just go with that. So the current would equal 0.47 amps. And that's pretty much all the values you could figure out with in this circuit.
This
Bye!
is a circuit for the flame light, and it is a series circuit. And in this particular circuit, it is powered by a 9-volt battery. In this diagram, the negative side of the battery is shown by this black wire, and the positive side of the battery is shown by this red wire. We used a multimeter to find the current in the circuit, and we found that in this circuit it has 2.3 amps. We also found out that throughout this entire series circuit, the current stays constant. So using the data we already have, the 9 volts and the 2.3 amps, we were able to find the total resistance, which equals voltage divided by current. So we divided 9 by 2.3, and we found that the total resistance in the circuit is 3.9 ohms. So moving on from here, we need to find the total resistance per LED. So we know that there are 17 LED lights, and we also know that the total resistance is 3.9 ohms. So in order to find the resistance per LED, we have to divide 3.9 by 17. And when we do this, we find that the resistance per LED equals 0.23 ohms. Lastly, we need to find the voltage drop. So the voltage drop equals resistance times current. We know that the resistance per LED is 0.23, and the current is 2.3 amps. So we multiplied 0.23 times 2.3, and we got the voltage drop of 0.529 volts. Then we can conclude that the voltage drops the same amount for each LED light.
Okay, so I'm going to be explaining what a hybrid circuit is, and it can also be known as a combination circuit because it combines both the series circuit and the parallel circuit. So it also combines the components of a series and a parallel circuit. So this is a diagram of a hybrid circuit we tried to create, but sadly ours blew up. Some of the lights blew up because there was not enough voltage to power all the lights together. So this was our attempt, and so we had our 9-volt battery and the negative side, negative charge, going this way, so clockwise was our current, around to everything and back to the positive. And these circles are our LED lights. The orangish wire is our conductor and our wire. And so basically we have our series circuit on the outer side here, and this diagonal plus these two lines are our parallels of our entire circuit. And so we have in the series section of our circuit, the voltage drops each time it goes through, and each time it goes through the voltage drops the same amount, only because we have the same exact light bulbs, but the voltage does drop in the series section, which is the whole outer section here. But the current for the series section is the same through every resistor, which is also a resistor is also in our case the LEDs. And however, the sum of all the voltage drops, the voltage drops, the sum of them should add up to our total 9 volts. And the resistance of each add up to our total resistance in the beginning, which we can find with Ohm's law. Now to talk about our parallel circuits, these two, and this right here, this diagonal. Well, when our current gets to them, from our series it gets to the parallels. The parallels share the same voltage, but since the current is being divided and branches off, the current is different, but at the end they add up to our total current from the beginning, from these three. And also the voltage drop is the same, and so that's it for the parallel circuit, and that's about it for a hybrid circuit. Thank you.
Okay, so it's already opening.
Mr. Refund, what are you doing?
Brenda, I need to be prepared before I say anything.
What?
I need to be prepared before I say anything.
Miss Marissa, what is it that we're doing?
We are putting a battery on.
What does the battery do?
It's the power for our circuit. Power source.
And you're gonna put a circuit there.
Hot glue this on?
What?
Hot glue this on? Wait, what am I doing? I don't have enough. I don't have extra. Really? With those bolts?
What you doing, Brenda?
I am trying to figure out the curve.
Oh.
Find the curve.